Hello guys, welcome to this training. In this training we're going to learn about public key cryptography, in which we're going to have first explain a little bit here. So consider Alice and Bob needs to always agree on a very large prime number P and a generator G, and most importantly they also need to generate a random number D of A and then also a Bob doing D of B, and these are what we're going to call the private keys. Okay, so private key has generally very large random numbers which they are going to generate and then keep as secured. So we're going straight to replace, and then we're going to generate that private number for both Alice and then so here we are using OpenSSL as a tool to generate an RSA, which is going to give us the private number, and then the private number we want to generate, we want to protect it with AES centric AES 128, and then the key size we are inputting should have a maximum 1024 bits. So once we input that, is going to access that. Before we create that, what's the password that we want to put it in 1024 bits. So we're going to copy our password here. Could be any password at all that you want, and you access to confirm the password. So once we confirm, all our private key has basically been generated, so we can use this command to actually view the private key. Okay, so that is generally the entire private key which has basically been generated. We could also use this one to also give us a way to output it, okay, in a text file towards our view. It's the same private key, so paste that, and it asks us to basically input the password so that we can open the private key that we have basically generated for ourselves. So we can paste that, and there we are. So this basically gives us much detail. Remember that over here we had the coefficient, which is the generator, which we are seeing also here as the generator, okay, and then the various exponents, and then also the agreed values that we have is also provided, right, has been encrypted with the AES. Okay, so once we have generated a private key, the next is to actually, from here we can easily tell that we can now generate the public key. And the public key is using the generator, which is also in the RFC, towards the private key, and then mode P. P is a very large prime number, as we can see from here. So let's generate the public key for Alice. So to generate the public key for Alice, we're going to use the same OpenSSL, and then we say we're using RSA, and then pop out is going to issue the command out and then generate a file out here for us, which we call the public key. So public key is just running through the, so it asks us to input that again, password, copy, paste. Okay, so we have it. We can do for Alice has basically been generated over here. So this public key, we can actually open the public key with this command to open it up. So that is the public key that's basically been generated. And this public key can be shared with any other person over the network. It's open, everybody can see it, but the private key is kept private and very secure. So we can assume that we're going to encrypt a message with Alice public key. So you got this message here. So we actually outputting the message, creating a message in which we have input secrets no more. So this is English, we all know this. And then the next is for us that we can actually look at the content of this with the cat command, which you already know. So that's the cat command, or we can actually display it in hexadecimal format as well as in ASCII characters. Contents, and then we can have it basically. It's also similar, also displays it in hex and ASCII characters, trying to install information. All right, so here we are with our answers right here for us as we use the the previous command. So can use this, which also gives us roughly the same thing in both hexadecimal, and then also then of course we can also have just displayed it in binary format. Okay, so these are just methods that we are using to display the public key that we have. So the next is for us to encrypt the message using Alice public key, assuming that we are sending message to Alice. So you paste that. So you have OpenSSL, and you see encrypt. We encrypt what the with Alice public key. We want to increase this plain text, and then the output of it is going to a ciphertext for Alice. So based on this is done, we can do the ls-al. Then we can see the file which has also been moved here. That was the plain text, and this is the ciphertext. So let's go ahead to use we can always, of course, we can do the SSD to look at the content of what we have just done. Is that yes, and here we are. You can see that because it's ciphertext, nothing is clear, right? Fully ciphered and fully encrypted at both sides. So if Alice wants to decrypt this message because it has been encrypted with Alice public key, it's only Alice which has the private key in order to decrypt this message. So we paste for Alice to basically decrypt. So Alice has decrypted the message, and he has actually moved it to a folder called decrypted by alice.txt, which of course we can do. Okay, so we paste that. All right, so that is that, and then so currently Alice has actually decrypted the message using his private key, so we can, and then the output is in .txt-al to see what's the further we go. So we have Alice decrypted alice.txt. So we expect that this file should be plain. We can actually decide to look at it. Try to do a cut of the one, and then that is basically that. So this is how we can actually add and decrypt information, first by looking at generating a random private key example of what we have just done, and basically that's all. All right, so that is that in hexadecimal. Also explain the testing, and there's some binary here, so we can also look at this one. All right, so